Hi, my name is Miguel Renom, and in this video, I will present our work exploring the technical reasoning hypothesis in digital environments. Now, to state something obvious, a lot of our interactions with physical objects involve using tools. For example, we use screwdrivers to drive screws through walls, we use hammers to pound nails, we use knives to cut apples. And I'm just citing usual uses for these tools, but tool use also comes in the form of unusual uses, such as when we repurpose a knife as a screwdriver. Now, a traditional view in cognitive science is that tool use is powered by sensory-motor knowledge, that is, unconscious procedural knowledge about how to manipulate these objects. But another account comes from the side of the technical reasoning hypothesis, which posits that tool use is a product of reasoning about object interactions based on knowledge of technical principles. So let me use an example to illustrate this. Suppose you have an apple in this initial state, and you want to slice it so that it looks like here in the goal state. What the technical reasoning hypothesis says is that we possess something called mechanical knowledge that tells us that in order to slice something, we can, for example, cut it. That is, we have knowledge of the cutting principle. But what do we know about this cutting principle exactly? Now, let's assume for a minute that we all know how to cut something because we have done it in the past. So we understand what the movement of the tool should be relative to the target object. But what we also need to understand in order to cut something is what the properties of the cutting object should be relative to the target object. And in this case, it should be something that is at least sharper and harder than the target object. In the case of an apple, we could, for example, find a kitchen knife fulfilling these properties. But by this standard, we can also understand here why we could pick up something else, for example, a credit card, and then repurpose it to cut the apple because it fulfills the properties of the cutting principle. That is, it is something that is sharper and harder than the apple. Now, repurposing is not exclusive of physical objects, and in fact, we have examples in the HCI literature that discuss users appropriating technology by repurposing digital environments for their own needs, and also cases of novel digital tools in whose studies the participants managed to repurpose them in unexpected ways. However, what we notice is that this is not as frequent or at least as easy as it is with physical tools. So that motivated the question of whether when users manage to repurpose digital tools, we can study it as an instance of technical reasoning. So we implemented a very simple text editing environment with basic standard commands, and we designed a task where we asked participants to indent the first paragraph. So they had this initial state of the editor and had to use any command available in order to get it to this state, that is, following the indentation marked by the guideline. So in a session, every trial required them to complete the same task, and that is indent the first paragraph using any available command. And what we did is that for every new trial, we disabled the commands that were used before to complete it. So the rationale was that if we disabled commands, they would have less of them to use and therefore eventually would have to repurpose the remaining ones in order to achieve the goal. So for example, if in one trial they used the spacebar to insert spaces in front of the paragraph, the spacebar would be disabled for any subsequent trials. So through pilot testing, we identified some usual solutions. For example, using the ruler to adjust the indentation in the paragraph, or using the spacebar to insert spaces in front of the sentence, like I said before, or using the tab key to insert a tabulator character, which was purposefully designed to be a bad solution because, as you can see, it's way beyond the guideline. But we also identified some unusual uses of commands, for example, copying existing spaces and pasting them in front of the sentence, or also inserting characters in front, visible characters, and then using color to paint them white so they become invisible when not selected. The protocol involved 16 participants, and they all were given the same task. But each of them went through as many trials as solutions or different techniques they could show us, which resulted in participants having different numbers of trials. Through all the sessions, they all were asked to think aloud so we could take notes and analyze them later. The results were that most participants repurposed commands, be that using the clipboard solution or the color solution. But in general, all of them were able to use the spacebar, 14 used the ruler, 11 insisted on using the tabulator even though it was a bad solution, 7 were able to show us a clipboard solution, and 5 the color solution. Looking at the different types of commands that were tried before finding each solution, we noticed that the clipboard and the color solutions, that is, the unusual solutions, were the ones that involved the most different types of commands before being used, which suggests that there was an increased exploration associated with them. We also took self-reported measures of experience with computers and creative personality and found that they associated with finding more alternative solutions. But in particular, creativity showed a stronger association and one particular interesting association with a repurposing case. So in terms of the qualitative analysis, we noticed that all participants had an idea of what would be the proper action for what was being asked of them. So they all had a sense of a common practice around indentation. And some even had biases or even felt blocked associated with their experience of how to do this. All of them had previous experience with text editors, so they were able to tell us how they would do it if they were in Word or Google Docs. And some even had created a sense of what's good practice versus what's bad practice in order to indent a paragraph, comparing some of the unusual solutions to bad uses of other applications. So in general, what we noticed is that all of the participants elicited some sense or knowledge of how digital text mechanics work. Some of them elicited knowledge of what properties of characters could help them simulate or emulate an indentation effect. And some even were able to express analogies with other uses of other digital environments, such as, for example, comparing the color solution to masking in Photoshop. So from these results, we found evidence that participants elicited a thought process that we deemed compatible with technical reasoning. That is, that they showed us a form of mechanical knowledge of text editing environments and also of the properties of text objects in order to achieve the goal. But we also had 5 participants who performed only usual solutions, which we associate to a form of functional fixedness. The implication is that we can leverage technical reasoning to design interactions based on tools that, instead of focusing on specific objects to interact with, are focused on the properties of these objects, thus following a sense of mechanical knowledge to decide what makes sense to interact with and what not. So in sum, we introduced the community to the technical reasoning hypothesis, and we showed that participants in our study elicited a thought process compatible with technical reasoning. We identify interesting avenues for future work in investigating other classes of mechanical knowledge, such as, for example, that associated with graphical objects or spreadsheets. Also, it would be interesting to investigate other factors or personality traits involved in digital tool repurposing, for instance, problem-solving skills. And ultimately, it would be interesting to design prototypes or digital tools that are oriented to specific properties of objects rather than specific objects of the digital environment. So with that, I conclude this video, and thank you very much for listening up to here, hoping that you can make time to read the paper.